Hi everyone, I'm Marian Bludau and I'm going to present the paper Unfolding Edges, Adding Context to Edges in Multivariate Graph Visualization, written together with my co-authors Marian Dörk and Tominski. The general idea for this work already originated in a co-design workshop for the visualization of historical social networks that we conducted in 2019 with social network and historical social network analysts. In fields like historical network analysis, transparency, and access to the context and attributes of a relation in a network is of critical importance for interpretation. To illustrate this, one of the participants, for example, stated the following. There is, of course, a big difference whether you are a family member, a correspondence partner, or whether you met at a congress during a coffee break. These are all relationships, but of course they have different weights in their interpretation. This is, for example, something we would like to see in a visualization. With unfolding edges, we are especially interested in the visualization of multivariate edge attributes in node link diagrams, which, for example, can include attributes such as edge type, direction, values, and uncertainty, or many other things. For these attributes, past research on graph visualization already offers a wide range of potential encoding techniques. Typical on-edge encoding strategies, for example, may make use of the fill of the edge by encoding, for instance, color, opacity, texture, or gradients. Typically, also the shape of the edge is used to encode information, especially line thickness, but also fuzziness, tapering of the edge, oscillation, line dashing, or line curvature. Oftentimes, network visualizations also make use of additional elements on an edge, such as arrowheads, added glyphs, embedded miniature visualizations, labels, or the use of multiple lines. And finally, in some cases, also animation is used for encoding of edge data. Typically, these types of edge encodings are applied globally to all edges, which oftentimes leads to visualizations that do not scale well, occlusion, or space issues. Approaches using interaction to enhance edge attribute details on demand are so far limited and mostly are used to reduce complexity or minimize occlusion, for example by filtering or edge bundling. In contrast to these techniques, our aim is to interactively add more detail to selected edges. With unfolding edges, we propose a general interaction concept for the in-situ and on-demand display of edge context in node link diagrams. Here, with unfolding, we refer to the metaphorical operation of folding, a fluid motion between folded and unfolded display states that are connected by animated transitions. In situ refers to embedding of contextual edge information directly on the edge. And with edge context, we summarize the existence of additional edge information, such as the classic notion of edge attributes or aggregated edges, as well as temporal information, spatial aspects, semantic annotations, or any combination. For that, our research does not only build on previous research on multivariate network visualization, but also on interaction concepts such as focus and context, semantic zoom, fluid interaction, and approaches inspired by folding operations and towards flexible visual analytics. The core idea of unfolding edges is to transform basic links dynamically into detailed representations of their associated edge attributes, using transitions to bridge the views. The foundation for that is a basic node link diagram. In a first step, after selection of an edge of interest, the overall graph layout is adapted via transformations such as zoom and rotation to make space and to create focus. Then edges are unfolded from a basic link to a more elaborate representation, depending on the underlying data attributes. In total, we defined 4 essential design goals, which are based on our collaborations and discussions with scholars from different domains and our prior literature research. First of all, we want to expose edge contexts and do this on demand. Then we want to display contextual information in situ, meaning we aim for embedding of contextual edge information directly on the edge. We also want to support continuous exploration. And finally, we want to design smooth, useful animated transitions between views that support the user's comprehension and engagement. Based on the mentioned design goals, we iteratively explored a design space of unfolding edges. The design space is guided by the following conceptual and design questions: how to visualize the edge context, how to embed the edge context in situ and how to facilitate navigation, and how to provide transitions that enhance orientation. Following Schneiderman's information seeking mantra, our approach starts with an overview and later adds detail on demand. Generally, for unfolding edges, we start with a basic node link diagram. Then we select an edge of interest, and by selecting it, unfold edge context in situ. Then we either close the edge context again by folding the information in and return to the overview, or we directly navigate to another edge of interest. When it comes to the visualization of the edge context, as the design of in-situ representations of edge context depends on various factors, there is no single solution that would satisfy all situations. Depending on the data, there may be a variety of possible edge contexts that can be shown, such as temporal, geospatial, structural, semantic, or forms of multivariate contexts. For the design, we conceptually distinguish between two basic options to represent edge context. A. Alterations of original edge representations, for instance by using on-edge encoding strategies directly on the original edge, or B. By creating a dedicated new edge context representation. In this case, unfolding an edge morphs its straight link into a visualization inset, which may take various forms, for example, a box or bubble with space for new representations. However, depending on the length of the edge of interest and the structure of the overall network, there may not be enough space to directly add contextual information. Therefore, our design space involves strategies for modifications of the general graph layout to put the edge of interest into focus and create space. Here, global strategies such as rotation, centering, and zoom affect the layout as a whole, while in contrast, local strategies like dimming, layout change, and layering tend to affect the layout only partially, for instance by changing individual nodes or edges. Besides strategies to create focus and space, our design goals also demand strategies to ensure access and possible navigation to the neighboring edges of an unfolded edge. These strategies include highlighting of relevant edges, enabling pan and zoom and draggable nodes, relocation of relevant edges, the use of cutouts in the inset on demand, or on-demand hiding of edge context. Finally, in order to smoothly unfold an edge and to bridge the involved potential drastic view changes, we make use of strategically designed transitions. The goal is to create coherent and comprehensible transitions that help users gain and maintain a sense of orientation in a potentially complex network. Here it is important to take into account various aspects, including the timing and staging of changes, minimizing perceptual impact, assessing the effects of animations on the performance, and maximizing the comprehension of layout changes with the help of strategic transitions. To validate our approach, we implemented 2 case studies in collaboration with domain experts in historical network analysis and computational social science. The prototypes were implemented using web technologies and the visualization library D3.js. For instance, this first prototype displays a visualization that shows a Nobel Prize network, which includes many famous names, such as Albert Einstein. Here, edges between nodes may not only be based on one source, but can be constructed from multiple heterogeneous sources, including various additional attributes such as source type or temporal information or URLs to document sources. In order to give an overview of the contained edge attributes, the unfolding of an edge triggers a transition that fends out multiple sub-edges from the original edge, allowing additional on-edge encoding possibilities for each sub-edge. For example, color for source types, dashed lines for indirect connections, or order of the edges for temporal ordering. But our approach can also be used for more complex edge context representations, such as timelines. In the now shown variation of unfolding edges, with the same Nobel Prize data, the unfolding of an edge triggers a transition that changes the visualization substantially by first adjusting the global view on the graph layout and then embedding a timeline inset. This transition involves rotating and zooming the whole graph layout such that the edge of interest is aligned horizontally in the center of the view. By unfolding a timeline, it is possible, for example, to trace correspondences between two people over time, or to interpret the quality of a relationship in the network. Additionally, highlighting of relevant neighboring edges aims to facilitate continuous exploration of other edges. To address potential occlusion of other edges by the inset, the edge context may be temporarily hidden by reducing the opacity and moving it to the background. In the next example, the displayed visualization shows a claim and conflict network, where the actors and conflicts were extracted from headlines shared on Reddit. In this conflict network, which includes many countries such as China or political actors such as Donald Trump, not only the existence of the amount of conflicts may be of interest to researchers, but especially the types, directions, and topic of conflicts. Here it can be useful to directly show the conflict topics in textual form. In contrast to the Nobel Prize network, in this example, the selection of the edge in the network leads to an unfolding of a hierarchically structured list of conflicts. Red circles next to the conflicts indicate the number of sources for a conflict topic. To better understand the impact of unfolding edges, we also collected qualitative feedback in expert interviews carried out in the context of this case studies. We used two prototypes, the Nobel Prize network with the timeline inset and the conflict network. For both, an additional baseline version was created, where edge unfolding was disabled and edge context appeared in separate side panels on demand. Here, the purpose of the baseline versions was to compare our approach with the conventional methods and to learn more about the role of animation, in situ unfolding, and the involved layout changes. Using a Think Aloud protocol, we wanted to find out how participants would interact with the edge unfolding and how our solution is perceived compared to traditional approaches. Overall, none of the participants had problems understanding the functionality and transitions of unfolding edges. The in-situ integration of edge context was perceived as natural and visually pleasing. For example, some stated, "So it feels more natural, it's as if we are opening the edge." Or, "I love that everything always remains inserted in the network in a sense, but without being confusing, just pretty clever." Also, "This is beautiful, I mean this is very aesthetically pleasing." However, for some participants, the appreciation of visuals did not necessarily translate to usefulness, and especially the rotation led to irritations and overall polarized opinions. For example, in my opinion, it's a visual gimmick that makes no sense to me as a user and gives no added value, but on the contrary, irritates me. In total, all participants stated that general access to contextual edge information is directly relevant for their research, and even a skeptical participant expressed interest in hybrid approaches of unfolding edges mixed with classic separated detail panels. In total, our results indicate that while some implementation details result in polarized opinions, the unfolding of edges can create visually pleasing and useful representations, thanks to a more direct and transitioned embedding of contextual information. While some users may prefer simpler or more familiar representations of data, the feedback also suggests that the transition context embedding may have positive effects on user engagement. Participants stated that the general possibility of accessing the edge context showed usefulness for the validation and interpretation of relations in networks. We see usefulness of our approach, especially when the observation and validation of individual edges is of high interest for the interpretation of the data. So far, our approach is limited to unfolding of single edges. Comparing edge context is hence difficult and demands back and forth movement between edges. Furthermore, our approach is based on node link diagrams and inherits the advantages and disadvantages. With unfolding edges, we do not aim to address general scalability and hairball issues of node link diagrams. For example, very dense networks with many overlaying edges and other elements can make the selection of edges difficult and may demand further interaction techniques such as edge lenses. Many design decisions, especially of the visualized context, may remain use case dependent and should be considered based on the needs to visualize specific aspects of the data. Depending on the selected design strategies, for instance, the use of transitions, layout changes may also have distracting or disorienting effects and should be considered carefully for each use case. For future research, we especially possibilities to foreshadow unfoldable edge context and support of direct comparison of multiple edges are promising. Furthermore, our design space still offers room for further exploration and more systematic evaluation. To conclude, we also want to mention that the prototypes and the source code are available online. Finally, with this research, we hope to inspire visually coherent and well-transitioned representations of the usually hidden edge context, and by that facilitate the critical interpretation of network data through interactive visualization. Thank you.